Hey, what's up? It's Wick for Wikimedia, and today I'm going to talk about digital audio. So I'm going to talk about the sample rate and bit depth. The act of capturing an amplitude value is called sampling. A sample is actually a static representation of a waveform in time. The amount of samples that are taken per second is what's called the sample rate. If we sample a 20 kHz frequency with a sample rate of 20 kHz, we only have one sample per completed cycle. To capture the positive and negative side of the cycle, we'll need to have a sampling rate that is double the frequency that we're sampling. In other words, to capture a 20 kHz frequency, we'll need to have a sample rate of at least 40 kHz. This is the basics of the Nyquist Theory by Harry Nyquist. The highest frequencies that we're sampling can cause some aliasing errors and other problems, and thus these can't be properly captured. We'll need to filter off the highest frequencies that we're sampling with a low-pass filter, and this is the reason we'll need to get a higher sampling rate than 40 kHz to properly capture a 20 kHz frequency. Keeping in mind that then the cutoff frequency of the filter is around 20 kHz, so we don't lose too much of the original signal. So we can say that sampling is capturing an amplitude value in time. This value is captured in a process called quantization. As well as with the time axis, digital systems have a certain resolution on the amplitude axis. The higher this resolution is, the more accurate the digital representation of the waveform's amplitudes. This is determined by the bit depth of the recording. The higher the bit depth, the more dynamic range can be captured. So a 24-bit system has a higher resolution than a 16-bit system. A 16-bit recording has a theoretical dynamic range of 96 dB, whereas 24-bit audio has a theoretical dynamic range of 144 dB. You can imagine that mixing with audio that has a 24-bit resolution is much easier and more pleasant to mix with compared to 16-bit, since we literally have more values on the amplitude axis. So why a 44.1 kHz sample rate? This sample rate standard dates back to the days of video cassettes. It was chosen because it was higher than 40 kHz, and that was needed to replicate the 20 kHz audio, and it was mathematically compatible with both the European PAL as the United States NTSC standards for film. The 44.1 kHz sample rate with a 16-bit bit depth was also adopted as the audio quality for the standard audio CD. So this sample rate has been relevant for years, and it actually still is. Common sample rates that are used nowadays can be a bit higher. Not only does this mean that we can theoretically record higher frequencies, but it also means that we've got a lot more samples that are taken to represent our audio. Many operating systems and audio interfaces nowadays can support sampling rates up to 96 kHz or even up to 192 kHz, and this is giving a much higher audio quality and processing options. The filters and the AD converters that are being used by an audio interface are really crucial in determining what the quality of the interface is that's actually doing this conversion. The sampling rate that we're using in a project can be seen as its playback speed. Audio files in our project that are on the currently running sampling rate will play back at a normal speed. But if we force to play back a 48 kHz audio file in a project that's running at 44.1 kHz, it will sound slower and pitched down. When we play back files in a lower sample rate than the sample rate of the recording, we will hear a speed-up version played back faster in a higher pitch. Most DAWs, however, will give a dialog box upon importing the audio files when the sample rates are not corresponding to the current sample rate of the project. So it's kind of like a safety net. You gotta take note that recording on higher sample rates and bit depths will create higher resolution audio and thus much larger audio files to work with. We can actually quite simply calculate the approximate disk space that's needed to record our audio on. We take the sample rate times the bit depth, and that gives the amount of bits per second. If we multiply that bits per second by the length of the song, we get the amounts of bits for the length of the song. So let's calculate this for a song with a duration of 4 minutes, and that's 240 seconds. So then we take 44,100 times 16 bits, gives 705,600 bits per second. If we multiply that by 240, we get a huge number of bits per 240 seconds. We can easily convert the amount of bits per second to megabytes per second by dividing this by 8 to get the amount of bytes per second, dividing that by 1024 to get the amount of kilobytes per second, and dividing that by 1024 to get the amount of megabytes per second. This results in 20.1 megabytes for 4 minutes of digital audio at 16-bit and 44.1 sample rate. Multiply that by 2 and you get the amount of megabytes needed for a stereo track. Let's compare 1 minute of audio for different sample rates and bit depths. You can see that the higher the sample rate and bit depth are, the larger the file size gets. There's a number of reasons why we would want to choose to work with higher sample rates and bit depths. The first would be the better quality that the higher sample rate gives and the more dynamic range that the higher bit depth gives. Especially the higher bit depth is really pleasing to work with during mixing. Processing is also a lot more accurate on higher resolution material. Equalizers, reverbs, filters, etc. They all sound much better on higher sample rate material. This is the reason why many plugins use so-called upsampling techniques to internally work at higher sample rates when processing audio. Another reason to work on higher sample rates is when you need to apply time stretching or maybe even pitch correction. Because we've got so much more samples on higher sample rates, we've got a lot more accurate information about the frequencies. That means we can do a lot more accurate stretching and correction. And another reason to work at higher sample rates is, for example, when you're producing sound for DVDs. DVDs can handle sample rates up to 192 kHz on stereo material and 96 kHz for surround material. Here's a list of the most common sample rates found in the industry. Working on higher bit depth doesn't stress your computer out too much. Working on higher sample rates, however, will stress your computer a lot more, so you'll definitely need some more processing power if you don't have that. Keep in mind you won't be able to add as much tracks and as much plugins as you were used to when you worked at lower sample rates. To answer a much asked question, if we're going to be creating a mix which is going to end up on a CD, aren't we going to be mixing it down to 44.1 at 16 bits eventually? And that answer is yes, you are, but that's only in the very last stage after the mastering. So during mixing and during recording, we can work at these higher sample rates and bit depths, and only in the very last exporting stage of the master, we're going to sample it down to 44.1 and 16-bit if you're going to be burning this to a CD. If you want to know even more about sample rate and bit depth, you should head over to wikimedia.net, where I'm going to post an extended article in the audio tutorials section in the 3rd season, so you can find that right there. So I hope you've learned something today. If you want to know more about the upcoming tutorials, you should follow me on Google+ or Facebook or Twitter. As always, this was Wick for Wikimedia Tutorials. I thank you guys for watching. If you enjoyed it, please share, comment, and like this video. And I hope to see you guys soon. Peace!